This is my beautiful tree, Amy. I have lived in this house 34 years, and when I walked out the first time and saw the tree, I knew I had to buy the house. It's been my protector for 34 years, and now it's got sudden oak death.
In the 500 years since it first sprouted from a single acorn, this coast live oak tree outside Susan's house in West Marin County has endured a lot. Storms, drought, habitation by animals, and human encroachment. But the mighty oak may have finally met its match in a tiny organism called Phytophthora ramorum, which causes sudden oak death.
I don't know if I'm going to be able to stay with it. It's not looking very promising. It's not looking promising at all. You know, I said to my husband, I don't know if I can live in the house when it's gone. I cannot be here when they take it away.
P. ramorum is a fungus-like organism related to the one that caused the Irish potato famine of the 1840s. Once an oak is infected with the pathogen, the disease causes dramatic symptoms like bleeding cankers, brown leaves, and weakened limbs. Most trees die within 2 to 3 years.
Okay, so this is a clump of trees. They're all dead because we died recently. And then look at it here. The trail goes through what I call the tunnel of death. All these branches, all these trees are dead on top of the trail. I'm Matteo Garbellotto. I'm a forest pathologist at the University of California, Berkeley. A plant pathologist is a scientist who studies diseases of plants. This is beautiful. It's beautiful in its horror. I know sometimes we pathologists seem to see things are beautiful that are not really beautiful.
In 2000, Matteo Garbellotto was recruited to join a group of scientists investigating the mysterious mortality of thousands of oak trees in California since the mid-1990s. What are you seeing here?
Okay, what I see is healthy cambium here, and I see cambium that's being killed by Phytophthora ramorum. So all the brown area here is all colonized by the sudden oak death pathogen.
How does a tree work, and how does this disease affect the tree?
Well, you know, the cambium is the only part of the tree that's actually alive and capable of growing. So when Phytophthora ramorum kills the cambium, basically it makes it impossible for the tree to grow. And on top of that, this is the layer that's used by the tree to exchange nutrients from the crown into the roots. And then from the roots, as they go back up into the crown using the outer part of the wood. So nutrients cannot go up from the roots into the leaves, and then carbohydrates, sugars cannot go from the leaves into the roots. And both these flows are necessary for a plant to grow.
In the last decade, well over 1 million oak and tan oak trees in 14 counties in California, from Humboldt to Monterey, have died, with more than 1 million more infected. Tan oak is a member of the beech family, but although it's technically not an oak, tan oak populations like this one near Inverness are some of the hardest hit.
If you were to count how many tan oaks are alive, you would be down maybe in the 10th percentile. So at least 90% of the tan oaks in this forest stand are infected, and as you can see, they're dying.
The loss of oak and tan oaks may have dire ecological consequences, including soil erosion, increased fire risk, and loss of habitat for wildlife.
Yeah, though this is dead. I mean, at this point, you see.
Scientists still don't know how to stop the disease, but in recent years, they have found important clues. A major breakthrough for Matteo and his team came in 2001. They realized that the disease was being spread to oaks by other plants called host plants. These carriers, like Douglas fir, bay laurel, and redwood, often don't die, but they act as a breeding ground for the disease, whose spores can be spread by wind, rain, wildlife, and humans.
After about a year of research, we realized that it was not the oak that was giving infection to the other oak, but it actually was the bay trees that were in the middle that were infecting the oaks in the area.
Oh yes, on the leaf tips here, huh?
And this is also how we think the disease was introduced here, you know, through a carrier host, not bay, but maybe, you know, an ornamental plant, and the infection would have looked like something like this, so not very conspicuous, and those plants were traded, sold, and this is how the infection arrived in California, most likely.
In 2006, Matteo and his colleagues published a genetic analysis of the sudden oak death pathogen. Their study provided new evidence that the commercial plant trade inadvertently introduced the microbe to the United States. And while its exact origin remains a mystery, Research has confirmed that the pathogen can be spread to oaks and other wild plants by infected nursery plants. So far, more than 100 plant species have been found to be affected by P. ramorum, many of which are found in nurseries worldwide. Here in California, dozens of common nursery plants, like rhododendron and camellia, have been identified as carriers. It's a situation that's hit California's $3 billion nursery industry hard.
I've been working with nurseries for about 18 years now. This is by far the largest problem like this that we have faced.
Within the nursery industry, which is the third largest agricultural business in California, the disease has become such a major concern that several U.S. states and foreign countries have imposed strict regulations regarding the commercial trading of host plants shipped from California. And nurseries have been forced to shoulder an additional expense: the widespread testing of their plants for the disease.
The fact that Phytophthora ramorum has been found in California and in nurseries has drastically changed the way we do business. We have taken great steps in terms of certification and inspections of all nurseries in the state. In addition to that, nurseries that grow host plants are actually DNA tested.
More than a decade has passed since sudden oak death started killing California's oak and tan oak trees, and a cure has yet to be found. But efforts to understand and defeat the disease continue in earnest. In March 2007, the California Oak Mortality Task Force invited hundreds of plant pathologists, forestry managers, and regulators from around the world to Santa Rosa to discuss the very latest research and management strategies. They're also learning about the toll that this disease has taken on some of the residents of Northern California, like the Kashaya Pomo tribe in Sonoma County.
We are a culturally practicing tribe, and acorns and tan oaks are something that are very sacred to us, and so sudden oak death coming in and starting to affect us has been a very scary experience for us. And
within this seemingly dark landscape, there are some glimmers of hope. In recent years, biologists have found that treating individual oak trees with a phosphonate solution makes some trees resistant to the disease. But the treatment is time-consuming and expensive, and it doesn't always work.
Does this treatment have any effect on trees that are already infected, or is it a completely prophylactic treatment?
The bottom line is that it hasn't shown good efficacy in terms of holding back infections that are already established, which partly...
Ultimately, the most promising hope for a solution may lie in genetics. At UC Berkeley, Mateo's research group is working with the U.S. Forest Service on a 4-year project to sprout thousands of tan oak acorns from different regions of California. Their goal? To test whether some populations of tan oaks may have a genetic resistance to the pathogen, and if so, why?
In some respects, the way I look at this is that this is the future of tan oak in California. So if we have resistance in tan oak in California, we should be able to see some of that resistance through this experiment. And hopefully we may be able to harness this resistance, and we may be able to use it to replenish tan oak population that have been devastated by sudden oak death. And look,
it's a situation with precedent. 100 years ago, a fungal disease imported from Asia wiped out millions of chestnut trees in the eastern United States. Today, whether with genetic testing, better regulation of nurseries, or yet to be discovered strategies, scientists and forestry managers are increasing their efforts to ensure that California's oak and tan oak trees don't meet the same fate. But for now, the killer is still at large.
this pathogen is not going anywhere, it's staying here forever, and we have to learn how to live with it. And some management practices will actually favor the pathogen, and some management practices will actually slow down its spread. So we need to learn which ones are which.
Next time on Quest.